Hello, my name is Liam Fraser from Mr. Will's Calculus 12 class at Bill Crothers Secondary School. The purpose of my video is to create a step-by-step instructional video that can help my fellow students solve a particular question. The particular math question that I will be addressing is from the McGraw-Hill-Ryerson Calculus and Vectors 12 textbook, page 299, question number 11. This question is from Chapter 5 from the textbook and Unit 5 of our calculus curriculum. Unit 5 refers to the derivative of log and exponential functions. This question deals with functions that decay over time. This unit is about the derivatives of log and exponential functions, which includes ln and e. Ln and e are inverse functions of each other. I will now proceed to read through my entire question. My particular question is, a smoke detector contains about 0.2 milligrams of americium, Am-241, a radioactive element that decays over T years according to the relation m equals 0.2 multiplied by 0.5 to the power of T over 432.2, where m is the mass remaining in milligrams after T years. This problem is asking me to, in part A, the smoke detector will no longer work when the amount of Am-241 drops below half its initial value. Is it likely to fail while you own it? Justify your answer. Part B. If you buy a smoke detector today, how much of the Am-241 will remain after 50 years? And Part C. How long will it take for the amount of Am-241 to drop to 0.05 milligrams? The picture can be connected to this question by looking at the decrease of the amount of mass you have. The x-axis represents a very long period of time as the scale increases by thousands. This question requires you to use ln in order to solve for the time value. Ln is the inverse of e, and this question relates to Unit 5 due to the function having a number in the base and a variable in the exponent. I will now highlight specific points of each question asked. In Part A, the smoke detector will no longer work when the amount of Am-241 drops below half its initial value. Is it likely to fail when you own it? Justify your answer. This question is asking to solve for a time value that corresponds to a future amount. We are being asked to make a conclusion based off an answer that is reasonable. Part B. If you buy a smoke detector today, how much of the Am-241 will remain after 50 years? This question is asking you to solve for a future amount of the element based off the given time value. In Part C, how long will it take for the amount of Am-241 to drop to 0.05 milligrams? You're being asked to solve for the time value based off the remaining element given. My plan to solve this problem will be a step-by-step process for each individual question that is asked, starting with Part A. For Part A, you are asked to find the amount of Am-241 that is below half the initial value. In order to solve this, you need to set your m value to 0.1. 0.1 represents half the value of 0.2. Because of this, we know the answer must be the half-life of 432.2, although I will show the general way to solve for any future amount that you have. We are aware that 432.2 is the half-life, therefore it has to be the answer because it represents the time that it takes to lose half of its substance. Ln is the method that is used to solve when there is an unknown in the exponent. I start off my solution with the original equation of m equals 0.2 multiplied by 0.5 to the power of t over 432.2. I then set my original equation to equal 0.1 because it's half of 0.2. I then divide the 0.1 by 0.2, setting that equal to 0.5 to the power of t over 432.2. I get 0.5 equals 0.5 to the power of 432.2. I then divide each side by ln of 0.5 in order to get the exponent down. I then get 1 equals t over 432.2. I cross multiply to get t equals 432.2. My solution of 432.2 proves that it is not likely to fail while I own the smoke detector. This is because 432.2 is measured in years and it's far beyond the life of any human being. My plan to solve Part B. By using the initial function, I know that my t value will have to equal 50. I substitute 50 in for t, looking for my future value. Part B can be connected to the picture by finding the point on either the x or y axes to solve for the remaining amount of substance. I changed the x and y axis values to be smaller in order to see the slow decreasing value better. To solve part B, I know that my t value equals 50 because that is given in the question. My new equation is m equals 0.2 multiplied by 0.5 to the power of 50 over 432.2. m equals 0.2 multiplied by 0.5 to the power of 0.115687. m is equal to 0.2 multiplied by 0.92294, and my final m value is m equals 0.1846 milligrams. 0.1846 milligrams represents the amount of element left after 50 years of use. My plan to solve part C. In order to solve this question, I need to substitute 0.05 as my future value into the variable m. When I do this, I know I'm solving for the time value, and we will repeat the process that I did in part A by using ln. Part C can be connected to my picture, finding 0.05 on my y-axis and connecting it to its equivalent time on the x-axis. I once again change the values on my x-axis to see the slow decaying process over each 100 years. I set my m value to 0.05 milligrams to determine how long it will take for the AM241 to drop to 0.05 milligrams. 0.05 is equal to 0.2 multiplied by 0.5 to the power of t over 432.2. 0.05 divided by 0.2 is equal to 0.5 to the power of t over 432.2. 0.25 is equal to 0.5 to the power of t over 432.2. I divide each side by ln, so I got ln 0.25 divided by ln of 0.5 is equal to t over 432.2. I get 2 is equal to t over 432.2, and I cross multiply to get my variable by itself. My final answer is t equals 864.4. 864.4 represents the amount of years it will take for the element to drop to 0.05 milligrams. Exponential decay is often used with careers involved with nuclear power or many scientific fields such as the medical industry and research for diagnostic treatment.